The NASA ESA CSA James Webb Space Telescope will be the largest, most powerful telescope ever launched into space. This video will highlight the telescope's science goals, which cover a very broad range of themes and will tackle many open questions in astronomy. The James Webb Space Telescope follows in the footsteps of the Hubble Space Telescope as the next great space science observatory. Webb will reveal the hidden universe to our eyes, stars shrouded in clouds of dust, molecules in the atmospheres of other worlds, and light from the first stars and galaxies. With its suite of state-of-the-art instruments, Webb will push the frontiers of our knowledge of the solar system, of how stars and planets form, and of galaxy formation and evolution in new ways. Thanks to the rapidly evolving field of exoplanet studies, planets beyond our solar system, Webb will be able to contribute to key questions such as, is Earth unique? Do other planetary systems like ours exist? Are we alone in the universe? Webb will study in detail the atmospheres of a wide diversity of exoplanets. It will search for atmospheres similar to Earth's and for the signatures of key substances such as methane, water, oxygen, carbon dioxide, and complex organic molecules, in the exciting hope of finding the building blocks of life. In this way, Webb will complement ESA's Atmospheric Remote Sensing Infrared Exoplanet Large Survey, ARIEL, a space telescope that will study what exoplanets are made of, how they formed, and how they evolve. Closer to home, Webb will also study the outer planets in our own solar system. Many exoplanets resemble Neptune and Uranus. Thus, studying planets in our own solar neighbourhood can provide new insights for better understanding planetary formation in general. Stars transform the universe's simple elements into heavier elements and, through supernova explosions, spread them throughout the cosmos. Observing in the infrared part of the spectrum, Webb will be capable of peering through the dusty envelopes around newborn stars. Its superb sensitivity will also allow astronomers to directly investigate faint protostellar cores, the earliest stages of star birth. Webb will study brown dwarfs, dim objects with masses in between those of a planet and a star that are not themselves massive enough to start thermonuclear reactions and become fully fledged stars. Webb will determine how and why clouds of dust and gas collapse into stars or become gas giant planets or brown dwarfs. Webb will also see the most massive stars explode as supernovae and leave behind more clouds of dust and gas, along with the precious heavy metals that enrich the cosmos to form new generations of stars. For the first time in human history, we have the opportunity to directly observe the first stars and galaxies forming. Webb's infrared vision makes it a powerful time machine that will peer back over 13.5 billion years, pushing beyond the limits of Hubble's deep fields that showed us young galaxies when they were only a few 100 million years old and were small, compact, and irregular. Webb's infrared sensitivity will not only look back further in time, but will also reveal dramatically more information about stars and galaxies in the early universe. While Hubble looked at toddler galaxies, Webb will see the baby phase. Webb's data will also answer the compelling questions of how black holes formed and grew early on, and what influence they had on the formation and evolution of the early universe. Today's universe is populated by galaxies, cosmic islands made of hundreds of billions of stars. Their sizes and shapes are vastly different, holding clues to how they formed and evolved. In the first few billion years, the universe was very dynamic, with galaxies undergoing merging events or being ripped apart, and were peppered by supernova explosions from short-lived massive stars. Operating at infrared wavelengths, Webb can observe the bulk of the light from these primordial galaxies and reveal their dust-shrouded starbirth and matter-absorbing black holes. Webb will also shed light on dark matter, the material that fills the cosmos but is not directly visible. In this way, Webb will complement ESA's Euclid mission that will map the geometry of the universe and is specifically designed to study dark energy, the force behind the universe's accelerating expansion and dark matter. The James Webb Space Telescope is set to answer outstanding questions about the universe and to make breakthrough discoveries in all fields of astronomy. Stay tuned.